This is a problem from the 2004 AP exam, and it reads like this. The principal at Crest Middle School, which enrolls only 6th grade students and 7th grade students, is interested in determining how much time students at that school spend on homework each night. The table below shows the mean and standard deviation of the amount of time spent on homework each night in minutes for a random sample of 26th grade students and a separate random sample of 27th grade students at this school. Based on dot plots of these data, it is not unreasonable to assume that the distribution of times for each grade were approximately normally distributed. Part A, estimate the difference in mean time spent on homework for all 6th and 7th grade students in this school using an interval. Be sure to interpret your interval. We will not be doing Part B today. So we're supposed to make an estimate using an interval. That means a confidence interval. And when it says interpret your interval, that means we're going to be solving this the long way using the 4 steps we've been talking about the last few days in class. So let's get started with our first step, PPP, procedure, parameter, population. This is a problem where we have 2 samples. It says a random sample of 26th grade students and a separate random sample of 27th grade students. Because we're not pairing a specific 6th grader and a 7th grader, but we have 2 lists, we're going to be using a 2-sample t-interval. That's your procedure. The second step is your parameter. And with a 2-sample t-interval, we have 2 parameters, mu sub 1 and mu sub 2. Mu is always the mean, whether it be mu diff, mu 1, mu 2, or just mu. Mu is always going to be a mean. We have 2 groups of students here. We have 6th grade students and 7th grade students. And what we're looking at is the mean what? Well, it says in the problem a few times, it talks about the mean amount of time spent on homework each night. We see that at the beginning. We also see it in the question. Estimate the difference in mean time spent on homework. So mu 1 is the mean time spent on homework. And then the population. Look for a sample. Our first sample is 26th grade students. So our population for this group must be all 6th grade students. Mu 1 is the mean time spent on homework for all 6th grade students. Mu 2 is typically going to be the same introduction as mu sub 1. So if mu 1 is the mean time spent on homework, mu 2 is going to be mean time spent on homework. The difference here is going to be who the populations are. Our first sample was 26th grade students. Our second one is 27th grade students. So if our first population was all 6th grade students, this population is going to be all 7th grade students. So how do we word this? Mu 2 is the mean. The mean what? Mean time spent on homework. Who's our population? All 7th grade students. Now I'll let this go. Specifically here though, it does talk about the sample as being 6th grade students and 7th grade students at this school. So it's probably not a bad idea to mention that these are 6th grade students at Crest Middle School and 7th grade students at Crest Middle School. So we abbreviated Crest Middle School as CMS here. So our procedure is the 2-sample t-interval. We have 2 parameters, mu 1 and mu 2. They're both dealing with mean time spent on homework. Our first population is for all the 6th grade students at the school, and then the second population is all 7th grade students at the school. Step 2, check conditions. The first condition for a 2-sample t-interval is independent random samples. That means separate random samples, and it specifically says a random sample of 6th grade students and a separate random sample of 7th grade students. We already know that you're not going to have anybody in the 6th grade group that's part of the 7th grade group. So that's separate, and if that wasn't clear, they even said in the problem separate. So we do have independent random samples, and we can state that as our first condition. Make sure in this step that you mention the word independent, which means that they're separate, and that we have random samples, not just one sample, but we have a random sample of 26th grade students and a separate random sample of 27th grade students. 2 random samples that are independent. Second condition, we're looking for something that talks about normal. And underneath the chart, based on dot plots of these data, it is not unreasonable to assume that the distribution of times for each grade were approximately normally distributed. Yes, we have it right there. The sample size wasn't big enough. We don't have data to even graph, but this sentence we can flat out plagiarize. Unfortunately for you, you're going to copy it down. I've got cut and paste. Ha ha. And we literally are just going to plagiarize that line there and now we've got the normal condition met as well. So step 1, procedure, parameter, population. Step 2, check conditions. Step 3, carry out the procedure. So in step 3, we're going to use our formula for a 2-sample t-interval, and we're going to substitute in our numbers. Now, since mu1 was for 6th graders and mu2 was for 7th graders, let's make sure that x1 is for the 6th graders, x bar 2 is for the 7th graders. And we're going to use the standard deviation for the 6th graders as S1, and the standard deviation for the 7th graders as S2. So we're just going to start plugging in numbers from this chart here. Our two means are 27.3 and 47. We have our plus or minus. T star. In order to find T star, we need to know the degrees of freedom so we can use that chart. Unfortunately, to find the degrees of freedom, we're going to have to use our calculator. So let's go to our calculator, and we're going to go back to Stat Tests. And we're going to select from this list the 2-sample t-interval. We don't have data in lists here. We actually have the full-blown statistics for the mean and standard deviation of both groups. So where it says input, we're going to go to the right where it says stats and hit enter. And we're going to enter in the values for x bar 1 and s sub 1 and n sub 1 for this problem. X bar 1 was the mean for the 6th grade students, which was 27.3. Standard deviation was 10.8. The sample size were the number of students, and we said the sample size for both groups was 20. X bar 2 is the mean for the 7th grade students, which was 47.0. Standard deviation was 12.4. Sample size here was 20 as well. The last line, it says C level. It doesn't say the confidence level to use here. So really you could pick whatever you want to. Typically if one's not given, the default we'd like to use is 95%. So I'm going to write in 0.95 for C level. For pooled, the default is no. We're going to leave that as no. And then we'll go down to where it says calculate. When you hit enter, this is the answer to the question. So our answer is going to be negative 27.15 comma negative 12.25. Here's our degrees of freedom. It says 37.297. If you want to round this, you can. I'm fine if you say 37. If you want to give the decimal, you can as well. We are going to write this underneath our problem here. So I'm going to say the degrees of freedom, lowercase df, equals 37.3. And now we can use your table. We're going to look up 37.3 degrees of freedom and 95% confidence, and we'll figure out what T star is. So here we are at 95% confidence. You're not going to find 37 on this chart. The closest thing we can find is 30, which is the next number that's smaller than that. So remember, if you can't find your number on the chart, round down. So the closest thing we can find to 37 without going over is 30. We'll use that with 95% confidence, and we'll use this value, 2.042. We will eventually come up with a calculator program that will generate the exact value for T star, and you'll get that next week in class. But for right now, that's as good as we can do. Now we're going to substitute our standard deviations and our sample sizes underneath the square root. Now here's another little quick tip. Because we've used the 2-sample t-interval program on your calculator, this number here, negative 27.15 comma negative 12.25, is what you get if you were to crunch this out. Now officially our T star is at 100% accurate. We'll replace this with a little bit more accurate number next week, but it's as good as we can do on our table. But for the most part, if you were to crunch this out, basically your answer should match with what your calculator says here. So the good news is you don't have to type this into your calculator because that'd be a mess. You can just copy down the numbers here, and that's the answer to your interval. Negative 27.15 comma negative 12.25. We've carried out the procedure. We're on to step 4. We always start step 4 with we are, whatever percent confident you are. We're using 95%. If they don't give you a value, I like to use that as your default value. We are 95% confident that. Here's where the wording gets a little bit different. They want you to estimate the difference in mean time spent on homework for all 6th and 7th grade students in this school. So that's what we're 95% confident about. We're 95% confident that we're working with a difference in means. Anytime you're dealing with a 2-sample t, it's a difference in means. So I'm going to again kind of plagiarize this. We can't really copy what we have from the first line for this type of interval, but we're going to kind of use what's listed in the question. We're 95% confident that the difference in mean time spent on homework. And I do like to include this little blurb about the population for all 6th and 7th grade students in this school. And now we can list the interval. Is between the two numbers we got, negative 27.15 and negative 12.25. These numbers are minutes, so it's appropriate to give the units. So we're 95% confident that the difference in the times is somewhere between negative 27 and negative 12. That means 6th grade students are using about, on average, some value between those two numbers for their time. So that's how you set up a two-sample t-interval, and you'll have some examples of these on your homework assignment for tonight.